In our previous video, we talked about solutions, and we talked about how solutions are the numbers that will make a mathematical statement true. Well, in this video, we're going to talk about how do we graph solutions. How do we graph these numbers that make the mathematical statement true? Alright, well in this slide I have three mathematical statements. And again, I want to graph the numbers that will make each of these statements true. I want to represent those on a number line. Alright, so first let's set up our number line for the first one. X equals 3. So I'm going to put 0 here, 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. Okay? And this may seem like a really simple equation, but I want you to think about it in a specific way. And this is going to help you for the harder ones. Right? I want you to think about what number could I replace x with that would make this true. Right? And it should be pretty obvious to you that the only way this statement is going to be true is if x were 3. If I were to place x with 3, I would get this statement. 3 is equal to 3. Right? Which is true. In fact, 3 is the only number that would make that equation true. If I were to replace x with, let's say, 4, I would have 4 is equal to 3, which is obviously false. Right? 3 is the only number that would make that true. So how do I represent that on the number line? Well, 3 is my only solution. So I'm going to use a closed circle here at 3, which is saying this right here is my solution. The next one I have x is not equal to -5. Okay, x is not equal to -5. Again, let's get our number line ready. When you are doing your number lines, I always want you to have 0 in your graph. I always want to see where 0 is on your number line. All right, that's just a side note. Okay, so now let's go back to our statement here. X is not equal to -5. X is not equal to -5, right? So let's think, what numbers could I replace x with that would make that true? Well, let's see, would -5 make that true? -5 is not equal to -5. Nope, that doesn't make sense, because -5 is equal to -5, right? So that's false. Okay, so -5 is not a solution. Well, what numbers would work? Let's see, how about -3. -3 is not equal to -5. Alright, well that's true. -3 is not equal to -5. Yeah, that's true. Okay. What about a number like 2? 2 is not equal to -5. Yeah, that's true. So both of these were true. In fact, we could put any number here for x, and it would be true. The only number that wouldn't work is -5. So we could use any number except for -5, and it would be true. All right, so how do we represent that? All right, so we know that -5 is not a solution. So let's do an open circle there. And what we want to shade in, we want to use an open circle here, because we're saying that -5 is not a solution. Right? But we want to represent the fact that all other numbers are solutions. So how could we do that? We can use, we're going to shade in basically everything else on this number line. Both to the right and to the left. Right? Because we're saying that any number would be a solution except for -5. And I'm going to even shade in these arrows to say that the solutions, well, they keep going. There are all these numbers over here, and all these numbers to the left as well. Okay, so you really have to understand what this picture is showing us. This picture is showing us that all of these numbers are solutions except for this -5. Alright, number 3. I have x is greater than 6. Okay, let's set up our number line. And when you set up your number line, I want to mention that you don't have to put 0 in the middle. So I could put 0, let's say, here, if I wanted to. Okay, so as long as 0 is in your picture, we're good. It doesn't have to be in the middle. Alright, so let's think about what this graph might look like. All right, let's think about what numbers would make this true. All right, well, let's see. Would 6 be a solution? If I were to place x with 6, 6 is greater than 6. No, that's false. 6 is not bigger than 6. All right, well, what numbers would work? All right, well, numbers that are bigger than 6, obviously. So a number like 8, for example. 8 is bigger than 6. X is greater than 6. Yeah, that's true. Right? I could use any number that's bigger than 6. I could use 10. 10 is greater than 6. That's true. Or I could use a number like 6.5 is greater than 6. That's true. Okay, so I want to shade in all the numbers that are bigger than 6. I don't want to do numbers that are smaller than 6, right? Because if I used a number like, let's say, 4, 4 is greater than 6. No, that's false. Okay, so how would I represent that? All right, well, first of all, 6 is not a solution, right? So I'm going to use an open circle here at 6 to say that 6 is not a solution, right? And what we want to shade in is all the numbers that are greater than 6, right? That would be things like 7, 8, 9, 10, or 6.5, all these numbers over here. And why am I shading these numbers, right? Because these numbers here are the numbers that are bigger than 6. These are the numbers that would make this statement true, right? And then these numbers over here, these numbers are not solutions. These would not make that statement true, right? Because 4 is not bigger than 6, 3 is not bigger than 6. These are not solutions. Right? And what I want you to notice here is that in this picture, 6 is a boundary value, right? That's a term that we're probably going to use. You probably want to write that down. 6 is a boundary value, right? Because it separates the solutions from the non-solutions. This is the boundary. Over here we have the solutions. Over here, these are not solutions. Excuse me. Okay, so we have two other statements here. X is less than or equal to negative 28 is our fourth example here. Now let's set up our number line. So you're probably wondering, I don't want to count all the way up to negative 28. So how do we represent that in an efficient way? Well, here's how you can do that. Here's a little tip. All right, let's put 0. How about over here? All right, and let's count by something that would be a little bit more efficient. Let's count by tens. So this would be negative 10, negative 20, negative 30, negative 40. And let's think about, where would negative 28 be? Well, negative 28 would be in between negative 20 and 30. It's probably going to be closer to negative 30, right? So it's somewhere probably over here. So let's put it, how about there? And if you have room, you can put it underneath. I just didn't have room, so I put it up on top. Okay, so that's kind of a way that you can be a little bit more efficient. You don't have to draw 28 tick marks, right? So it's 10, 20, 30, 40. Negative 28 is about here. Okay? All right, so let's think about what numbers would be solutions to this. Okay, well, first thing you should test is going to be our boundary value, which is this number here, negative 28. Let's see if that's a solution. Okay, so negative 28. Negative 28 is less than or equal to negative 28. And that right there is true. Right? Because negative 28 is equal to negative 28. So that's true. Okay? So what other numbers would make that true? Right? Well, the numbers that are less than negative 28. So a number like negative 30 is less than or equal to negative 28. That's true. Okay? And basically what we're going to find is that all of these numbers here, less than negative 28, are going to make this true. Right? And the numbers that would not make that true are numbers that are over here, this side of the boundary. Right? Numbers like negative 20. Right? Negative 20 is less than or equal to negative 28. No, that's false. Okay? All right, so let's represent this on our number line. Okay, so first of all, negative 28, our boundary value, is a solution. So since it's a solution, I'm going to use a closed circle. Okay, and the numbers that are solutions are the numbers that are less than negative 28, these numbers over here. All right, and these numbers over here are not solutions. All right, so again, we have our boundary value, negative 28, which is a solution, so it's a closed circle. And then all these numbers over here are solutions. Right? Numbers like negative 30, negative 40, those are solutions. Right? These numbers are not. All right, this one, 32 is less than x. Okay, let's do this the same way. Let's again set up our number line. And I'm going to again count by tens, 10, 20, 30, 40. So 32 would be about here. All right, so 32 is less than x. Okay, so first of all, let's think about our boundary, which is our boundary number, which is going to be this number here, 32. All right, so if I replaced x with 32, would that be a true statement? Let's do that over here. 32 is less than 32. Well, is 32 smaller than 32? No, that's false. Okay, so in this case, 32 is not a solution. All right, so we know that 32 is not a solution. I'm going to go ahead and start the graph. So 32 is not a solution, so I'm going to use an open circle. It's not a solution. All right, so we have, again, we call this a boundary value because it's going to separate different regions. We have this region, we have this region. All right, so let's think about numbers that are, say, on the left side, on this region over here. Right, let's think about, for example, 20. Okay, so is 20 a solution? 32 is less than 20. Right, is 32 smaller than 20? No, that's false. Okay, so that's not a solution. Right, and again, what that tells us is that this whole region has numbers that are not solutions. None of these are solutions. Right, well, what about numbers over here? So let's see, how about the number 40? 32 is less than 40. Is that true? Yeah, 32 is less than 40. That's true. Okay, and what that's going to mean is that basically all of these numbers over here are solutions. Everything in this region here is a solution. All right, so now I have 4 problems here, and I want you to do these. Okay, so you're going to pause, and you're going to graph the solutions, right? And really think about what numbers would make these statements true. So go ahead and pause and graph them. All right, so I'm going to show you the answers. Okay, so 6, we have x is equal to 6. Right? The only solution would be 6. 6 here is the only solution. That's the only thing that would make this true, so you should have graphed just 6 like that. Number 7, x is less than 7. Okay, so you should have, take a look at your graph, you should have 7 as a boundary value. 7 is not a solution, right? If I were to put 7 here, 7 is less than 7. No, that's false. So 7 is not a solution, right? And that's why we have an open circle here. Okay? And you should have found out that all these numbers in this region, 6, 5, 4, 3.5, 0, all these numbers here, these would be solutions. They would make that statement true. Right? And the numbers in this region, to the right of the boundary, 8, 9, those would not make that statement true. So those are not solutions. Number 8 and 9, here's what you should have graphed. Number 8, we have our boundary value of negative 12. Right? And negative 12 is a solution. Right? And if I were to put negative 12 in, that's true. Right? Negative 12 is less than or equal to negative 12. So negative 12 is a solution. That's why it's a closed circle. And the numbers that would be solutions are solutions are these. These would make that statement true. So you should have shaded to the right. And notice I counted by 2's here, just to make my life easier. All right. Number 9 is kind of interesting. It says x can be any real number. X can be any real number. So that's basically saying x could be anything. All right. So any number would make this true. And so what I have done, if you take a look at this, is that I have shaded the whole number line, including the arrows, right? Because every single number is a solution. X could be any real number. All right, the last thing we're going to do, right? I have 3 graphs that are already graphed. And I want you to write the mathematical statement that would go for each of these graphs. Okay? Why don't you pause and see if you can come up with the mathematical statements for each of these graphs. All right, number 10. Here's the answer. If I look at this picture, I see that -5 is not a solution. And what are the solutions? They're all the numbers to the right of the boundary. Right? -4, -3, -2, all these numbers which happen to be bigger than -5. So my mathematical statement would be this. X is greater than -5. Right? And it's not going to be x is greater than or equal to, because -5 is not a solution. It has to be strictly bigger than -5. Okay? Number 11, what you should have written, if you look at this, -10 is not a solution. But everything else is. The numbers to the right of -10, the numbers to the left of -10. So the only thing that's not a solution is -10. So I would write this. X is not equal to -10. Right? Because x could be anything except -10. And then the last one, we have this picture here. We have this picture where 3 is a solution. It's a closed circle. And the solutions are all the numbers that are less than 3. All the numbers to the left of 3. So I would do this. X is less than or equal to 3. Right? Because x could be 3. It's a closed circle here. 3 is a solution. And then all the numbers to the left of 3 that are smaller than 3.